The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlin.com and navigate to the Resource Center. Parker Sporland, leading the charge.
Why has it really been that bad?
Fuck yeah, dude. You should see some of these case controllers, how they're mounted.
I guess they're not mounting them top side, they're mounting them underneath.
Are all underneath, and they're all half of them are Hill Phoenix cases. That stupid ass tray. When you slide it back in, it rips the comm wire out every time.
Maybe. Oh my god, is that? I don't know why that tastes like refrigeration oil. I'm hoping they didn't put refrigeration oil in my drink.
Yeah. Oh, you love it.
Really gross. Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wentzel, Devin Compass. Tell me about your week, buddy.
It's in Dixel startup hell. It's just, yeah. I'm on a store where like everything had to get redesigned on the fly and comm loops redone because there are so many case controllers on this CO2 rack that they split it up into 2 E2s, and it's just a ridiculous amount of case controllers. There's over 160.
Just regular XMs or what?
XM 670 and 9s, and there's not enough COM ports to make all these work, so like every COM port's overloaded from what they want. It's just a nightmare.
See, I thought I was on the same page up until you schooled me. I honestly thought you're allowed to have up to 30, right? Like 30 was the utmost max. Like they only want, I think, 27 or something like that.
25, but like 30, 32 with the COM port is the maximum amount of devices on the RS-45 architecture.
But see, I thought because you're can busting the other cases, like I thought it was just the masters, but no, it's not, huh?
No. It's 32 devices.
Oh, no. Let's do some simple math here. You said how many cases?
160. Case controllers. Ish. I lost count today because we found a bunch of cases where one island had 8 case controllers in it.
Oh, that's going to go well. All right, so let's just do 160 divided by at most times divided by 30. That's 6 different comm loops that you got to have there, Bella.
It's exactly what we have right now, and we're about to split another one up into 7 to make the 7th loop.
So wait a minute, and that's even doing 30. That's going to the utmost max that they really don't want to. If you did 25, it's definitely going to be 6. So does that mean you can still do 30 on comm 4A and 4B, or is it just?
Yes.
It's
per port. So it sucks ass. Like it's just a ton of case controllers. It's a massive amount of programming. It's a massive amount of doing everything. Everything had to get deleted for the most part because everything changed. So the manufacturer sent the program out. I ended up deleting all the case controllers because they were all jacked up and the addressing was just a nightmare. So I ended up having to make Excel sheets to make colored comm loops, to make addresses, and then we tried to address it today. There was 5 of us addressing cases, so that turned into a shit show because there was obviously some cases got misaddressed and stuff because there's 5 of us doing it. It was just a nightmare. And then the comm line had been redesigned 3 times now because stuff had gotten moved around, and jostled around. It would, yeah.
But wait a minute, isn't it the electrical engineer's job to make sure all that stuff doesn't happen?
Yeah, well, you can't have 50 on one print and one comm loop. So
Just saying, if you're drawing out the architecture for this, you do some homework.
we got the old, hey, send us the one-line drawings after you're done so we can update the prints. So I think we're down to 4 cases and that aren't on. And then it's just been an absolute nightmare because the GC is like just fighting this the entire time. So they scheduled the week of startup, they scheduled the floors to get done in the main electrical room. So the house electrician can't even finish trimming out like mains.
Who
So-
needs to be in the electrical room the week of startup? Oh my God, that's ridiculous. Who thinks of that?
Yeah, it's just chaos. So I don't know. Like we got the gas cooler. I got the Gunner gas cooler programmed and the CO2 racks prepped. Everything's going through. I still have to install a second IPro and I don't really care about that right now. It's off the side. This thing's basically there's 6 guys coming in to verify sensors tomorrow. So
Wait, second IPro? Why is there a second IPro?
because Hill Phoenix has this double flash gas bypass valves going on in a bunch of these racks. So instead of putting like a secondary valve driver, like a Danfoss or like a 0 to 10 volt valve driver, they're putting a second iPro in and raising it a secondary set point to give it like a backup high pressure or flash gas bypass valve.
So basically, you're controlling 520 on it, right? They might, whatever the dead band is of that one, go a little bit higher than that.
I've been changing them. And so what I don't like is you have 2 PID loops now, which is, I think, ridiculous. So what I've been doing is I've been enabling them off of load on the flash tank. And once the main iPro gets to 80% open, it enables the secondary iPro after a timer. It enables the secondary iPro, but if the receiver pressure spikes and there's no phase loss and there's compressor proofs, it enables the main iPro and overrides it and lets it do its thing. Or the secondary iPro lets it do its thing. So
Okay.
but under normal circumstances, I lock it out unless it's because the 2 PIDs thing is ridiculous. It runs horrible because you have 2 different loops, and even if you set it like slightly higher, it's if it gets in the other one's loop and starts opening, then the other one spirals out of control and slams shut, and then the other one slams shut, then they start opening back up. It's just all over the place. So I just let it do its thing.
Are they doing it because of the? I'm just thinking about this.
I think these are canned racks. Like they're starting to can their frames and stuff in their designs.
So I guess my question is, I guess the idea for this is so you can, because you could do the same thing because you have the EXD driver basically doing that, but
So
if you use a driver, you could enable it with the same enable that
Right.
not the same exact enable that you're doing for the iPro, but pilot relay something because you can't cross that voltage. Yeah.
So I wanted to use a Danfoss EKE because you could easily set up an EKE and give it the 0 to 10 volt signal off of the iPro or the flash gas bypass valve is usually always valve 2. So AO2 on the iPro is valve 2. AO1 is valve 1. So it's a 0 to 10 volt signal. I would rather give the EKE that 0 to 10 volt signal off of valve 2 if you really needed 2 of them to work in tandem. That way you could open and close 2 of them in tandem. And then you could just disable the EKE with a relay when you don't need the secondary valve in the wintertime when the load's low. That's a much better way to do it, I think.
So have them running in tandem all the time so they don't interfere with each other's loop. And then just basically when it reaches a certain ambient outside, you're just like, you know what? No, we don't need 2 of them rolling. And it would just
in a rack load.
and it would just relearn its, it would relearn its PID loop with just having the one rolling.
Yeah, I'm be interested to see if I'm actually going to need this or not because this rack I may need 2 flash gas bypass valves. The receiver's 8 feet tall. It's huge. I don't think I have the case load for it, but it's there. So
No, you said the gas cooler is pretty damn big on this too, right? How many cans is that?
it's like a 8 or 9 fan.
Oh, single row?
Single row. It's tall though, like super tall. It's a pretty good sized gas cooler.
You were telling me what the size was as far as the system, so I'm assuming you're probably almost 1 million BQ as far as total heat rejection, probably.
890 or 870 something.
Is that total or is that
that was evaporator?
That's what I'm saying.
Yeah.
Add the total heat rejection, you're probably talking damn near close to, because it's usually like 1.6 or 1.7. You multiply it by, I think.
Yeah, it's got to be under 1 million. They're also need an on-site engineer. We'll see how it goes. I'm not a big fan of the double E2 thing. I would have rather had an E1 or E3, and like CC200s would have been a much better option. Yeah, they're more expensive, but at the same time, like they're just so much faster and just better all around.
Newer technology.
Well, it's newer technology, but also like Ethernet is able to carry a lot more traffic than RS-485.
Yeah. What did Brian say? How many we have on them?
A lot. I forget what it is, but then so now it's not just limited to that because you could use routers. And what I like about the E3 with that is, say if you have a router like on a case floor, you could essentially get into the E3 from that router, or you could plug in any CC200 with a splitter and get into that E3. Yeah. So it's protected. It's not on the customer's network, but it's on the backbone side of that, especially if it's Ethernet or backend over Ethernet. Like you could hop on there and get on there and see everything.
Yeah, because you have on the back of the E3, you have the Ethernet 1 and Ethernet 0, right? The one is for their, I think one for their loop, their private network, and I think
you could do either one.
Yeah, so whatever it is, so one you could have running all the CC200s, and then whatever.
Yeah, which is much better, I think, for that. So I don't know. The XMs they're nice for like single cases, but when you end up like a Hussman case, that becomes a problem. 3 case controllers on a 12-foot case is insane.
And then you think about it, right? Like it's not like each pressure transducer. I think you can share a pressure transducer through the XMs if they're canned, right?
You can. So like I have that is where my problem came in, because originally this is a Hill store, and then a bunch of Hussman cases got ordered too. So it's like all the Hill programming was set up for that. So I had to set up a bunch of them for LAN for that, and then some random cases showed up where they had 4 coils in one case, and it had 4 transducers in a row, and I'm like, this is insane.
Good thing it's CO2, so they have a place for the piping. Otherwise, if it was DX, you're crowding in there.
I go, there is an 80% chance that this suction line is 100% plugged with solder.
What?
I don't know. Find out when we fire it up, but I don't know. That was my hell of trying to get everything addressed and then trying to get everything shoved back in these cabinets. And yeah, it's just a never-ending nightmare.
Yeah, they need to start putting a spec in the what's it had, a couple sheet of wire, a couple sheet of seal tight or whatever. But having a expansion loop, so to speak, for not just the comm loop, but like for even the high voltage.
Well, 80% of the cases you cannot get the tray all the way out because of the high voltage.
That's my point. So have it spec'd in there that you need whatever the length is between connection to connection, you have to add some sort of wrap of what, I don't know, 3 feet on the other side for extension, so you can actually pull that tray out. Because even like on the freezer ones, like sometimes they have those relays in there, and screw yourself if you're trying to keep that and the relays get knocked out. It's not fun.
Yeah, or you try to put it back in and it pulls the comm line out of the XM 74 times. The big one that really got me and I was irritated as shit is every multiple case only had 1 case display. So you had to unwire it every time.
It'd be easy, but it'd be all right if it would have been on the top, but like the fact that it's on the bottom,
yeah,
not cool.
You had to unwire it and then wire it over to the next one, and then you had to pull the plugs on everything and then pull the display out and move it down to the next one.
Would have been an awesome application for a CC200.
Oh, 100%. Like it would have been way better. But yeah, that was my week. And then prepping for startup and trying to get vacuums pulled and trying to get everything going with that. So I don't know. We'll see how tomorrow looks. We were under 300 when I left, so it should be good.
Yeah. I'll talk to you tomorrow. I'll find out. I'm in Colorado again, training again. I'm going to be here for one more week. And then I think he wants to do maybe another week of more advanced stuff. Cause like I've been going through all basic refrigeration with all those guys. As anyone knows, there's not one set, there's not refrigeration mechanics fall out of the sky, right? So we have to make the ones that we have. And so the problem is like, you have one guy that might come from appliances, one guy that comes from HVAC, another guy that does residential. So it's trying to take all these people that have traits that they've been doing and diagnosing and breaking that and showing them the right way to do things so they don't do these self-inflicted callbacks. There was a couple of times this week where we saw a rack where 2 of the cases were satisfying because the EPR wasn't set low enough. And because it was too low, it was basically shutting off the mechanical sport valve and backing up a whole bunch of refrigerant behind it. And then no liquid line solenoid on there. So then it's just letting go a whole bunch of liquid in there. So intermittently, the medium temp was just flooding out. 1, because the superheat was way too low. And 2, because it kept cycling. So it kept stacking a whole bunch of liquid refrigerant in the suction line. The EPR would let go and just rocket it. So when I asked him, I'm like, how many times do you think that this has came in as far as like a rack failure? So just finding those things and making commonalities between things. We did a lot of oil stuff today or yesterday, and then no oil bath this week. So that's cool. And then today was electrical day. And so every single store that I've been at so far, I've had to write a schematic for the compressors and stuff. I called Hussman for a Hail Mary, and I was like, the rack's not that old. It was like, they got to store it, right? And sent an email to a buddy of mine, and he goes, Brett, that rack is old. I'm like, it's 2004.
Yeah, it's like,
he's like,
Windows.
It doesn't matter.
Like Windows 2 or Windows 2000.
Windows 95, maybe. Yeah, maybe. Or XP. I think XP was around then. Stop it. That's what I was doing this week.
Most of I've had pretty good luck with Huss. So I asked for a 15-year-old P&ID diagram and they had it.
I think 20 years might be the limit. And then there's other manufacturers where they bought other manufacturers, and then you go to call them for things and they're like, no, that's gone. We only kept it. They kept it for 10 years and they're like, nope, gone. Done.
See, the Tyler manuals were always pretty good, like with their rack wiring for that stuff. But yeah, like I've had to make a ton of wiring diagrams. Like I use TinyCAD. It's just a shitty electrical CAD program. It's free and takes some getting used to. But once you get it set up, like you can make some decent backyard diagrams.
Yeah.
So you probably have AutoCAD because you're fancy.
No, I do have AutoCAD, but I don't use it for no. I have. Yeah, I think I do have AutoCAD on my other computer at home. But yeah, that's because I look at a lot of different prints that I need it for, a lot of engineering drawings, obviously.
I have the View version, and then I have the Hobby version. But you start making wiring diagrams, you're going to suspend your stuff.
Oh, really?
Yeah.
Wow. So what do you want to talk about?
I don't know. You said you wanted to talk about basic refrigeration.
Sure. So we were just going. So one of the things that we did do this week, so you always start, like we talked about it before, understanding like how things are supposed to be run as far as the reefer schedule. One of the things that I'm constantly teaching is look at the case and talk to the customer for a little bit and scope out what's going on. Look at the case and see if there's anything blatant, the fan out, whatever. But one of the most important things is checking and verifying the actual case location, because in a lot of stores lately that I've seen is that they're wrong. You could have someone working on a case and they're not working on the right thing. So usually I have them verify that. And then once we do that, it's off to the rack. I'm not going to go adjust anything all willy-nilly, but before I do that, we look at the frost pattern, see if there's anything like given away, but then look at the rack and see what we have going on up there. And when I was teaching the guys, I was look at the refrigeration schedule. And it was really hairy at one point because they're like, do we have to do this every single time? I said, we're going really deep into it, checking the pressure transducers for calibration, because I don't know if anyone's ever checked that. We don't know if it's running 10 or 15 pounds lower than what it should be. So once you get your sensor, your pressure transducer calibrated, how often, honestly, Kevin, how often did they fall out of adjustment?
Never. Here's my thing with that. Like 99% of the time when guys are calibrating pressure transducers and they're off by 2 or 3 pounds, that's your gauges.
Yes. And that's why I had them check it. So a lot of these stores I've been training at, they've had conversions done, right? And a lot of times people don't use digital gauges or they don't calibrate them. And they were, like you said, you had an instance where you had someone calibrate something and every single pressure transducer was like exactly 3 PSI off.
That happens every time they come out and do a commissioning, same company.
Yeah. So basically going through and doing something like that, right? And verifying that the pressure transducer, as I said, if you do it once at the store that you're at, unless there another problem comes arise, like you should only have to check your store once if you do it properly. Everything's calibrated or whatever. And that was the other thing too, like you can't be using a set of 410A gauges for checking superheat or calibrating pressure transducers. Like if every increment is 5 PSI, how the hell do you know like actually where you're at?
L-Tech ones are so cheap and they're pretty damn accurate. Those lollipop digitals, that's what I use. Or the Appions when they had the other ones before they came out with their new ones. That's what I use to calibrate transducers and check them. That is the best way to do it, hands down. Not with mechanical gauges. You shouldn't be checking it. You should be checking pressure transducers that are 10 times more accurate with a mechanical gauge. It's not the same thing. Every time I see them offset, they're generally not. Pressure transducers usually aren't off by 1 or 2 pounds. They're usually off either like super high or super low. And it's pretty rare.
I had an argument with Eric Kaiser from True Tech Tools because I was like, I like my analog gauges. He's yeah, but how accurate? I was like, these ones say they're within 2%.
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Yeah, that's when they come out of the factory, when they're banging around the back of your truck, falling off a case and all that other stuff. How accurate are they now? I'm like, 2%? No, they're not at all. So 100% you're right. Making sure that whatever you're using, A, is calibrated, and B, also something that I've had to get accustomed to. I'm looking at my PT chart because everywhere else in the world is at sea level. I'm in Colorado. They have a lower atmospheric pressure. So I had to set my PT chart for high sea level for the first time, like ever, except for the other times I've been here. But that's something that because everywhere else in the world, I'll set it for sea level. And then I come here and they're like, you're off by a couple of minutes. No, I'm not. I'm like, shit. Then I forgot to switch it over to high.
That's the inner boomer in you.
Why? What are you talking about?
Zero it out at where you're at. You're fine.
No, I understand that, but I'm saying no, when I'm using the PT Pro on my phone.
Oh.
When I'm actually looking up, like what we're talking about saturation, right? So I'll say, oh, it's this saturation, so it's this pressure. And they're like, no, it's not. I'm like, what do you mean? I'm like, shit, I forgot to set it to sea level because it's off by a couple pounds.
My gauge tells me that.
My phone does not, unless I tell my phone that I'm in Colorado. Jerk. Anyway, so once again, making sure everything's all calibrated as far as your pressure transducers, temperature sensors, if you're using that for any kind of type of control. I found out that I really hate when people duplicate sensors for the discharge and use them on the drop leg.
Oh yeah, that's the good old clone on Danfoss.
Yeah, man. Like, here's the problem.
It's got a lag.
Not just the lag, but the fact that when you have a rack that's not fully loaded, because of the magic, cut my efficiency down by 75% doors, causes a whole bunch of lazy liquid feed, right, to start on, for one thing, especially because then the pressure on your discharge ends up being equal or maybe a half a pound heavier than your liquid, and it doesn't want to move. Not at all.
Yeah.
Oh,
I'm not a big fan of that. When we do those jobs, I argue with people all the time about it. I want to install drop like transducers. Just pay the money to get them installed. Right.
so let me ask you a question, because it was part of an energy retrofit.
Yep.
Yeah, I don't even explain it before.
But I've been ordering packed angle valves. We pump it down, cut them in.
The company I'm working with is not doing the energy conversions. There's a third party that is, yeah.
No, it's more and more expensive to do it, but like it's the right way to do it, and you're getting better control out of it, and it's not having a pressure drop. And then here's the other like thing: when people do that, I don't want to do that, because every hot gas rack, when it has a DDR, guess what happens when the DDR kicks in? You jump your fans up. You raise up your fans that aren't actually the correct pressure, because the discharge transducers before the DDR, it sees a 20, 30 pound rise, maybe 40 if you get somebody feeling a little spicy. And now your fans ramped up 40% more. Now your liquid's logging on the roof in the wintertime.
Yeah, and that's actually, I remember I was trying to get some more defrost power out of the rack today because it was cool gas. So I was like, I'm just going to raise the set, because they have the minimum set for 85 degrees. So I was just like, I'm going to raise it for 95, because I saw what was happening. Exactly what you described. Basically, the drop leg, I was trying to bury it down from running high, right? And yeah, it don't work too well.
Yeah, I'm convinced that all the cool gas racks need to get converted to high gas.
I know you're going to die on this hill.
I'm going to die on this hill. I don't care. I don't care about all the BTU numbers, because with as much real world experience as I've seen it, hot gas beats cool gas every single time.
For how many times that you call me a boomer?
It's the truth, is it not?
No.
Yeah, yes, it is. Hot gas beats cool gas every single time.
All right, those X amount of BTUs from the sensible heat might do something.
Yeah, sure. I sure defrost a lot less hot gas coils.
Yeah.
Probably cool gas. It's just, it has its place, but yeah. But making sure that pressure transducers there is key.
Yeah, I think I'm going to try to convince the people that I'm working with that they need to convince the customer that they need to move it. Unfortunately, there's no angle valve there, and I'm really against, oh, here's a Schrader, let's just pack that sucker on there. You know what I mean?
No, I'm not doing that. I'm just burning an angle valve. Angle valves are cheap.
Yeah, but pumping down the rack can be time intensive if the rack is 20 odd years old, right?
It's not going to hold. You just you just do your thing.
Anyway, also teaching them to check the TD of the condenser, right? And when to check it above so we have degrees. What?
Those racks, not TD, not good.
No, I know. This one's the one's 16 point something. The other one's 11 on the low temp. It's not horrible. But yeah, but I'm also in Colorado, right? Having them check that. What else are we talking about? I'm sorry. We were talking about a whole bunch of stuff.
The temps in Colorado are weird. Both times I've been out there, it was hotter than hell, but like zero humidity.
Oh yeah. By the end of the week, my nose is bleeding because it's so damn dry. People think it's dry in Texas. I mean,
no, it's not. Houston was horrible.
Yeah, Houston is an armpit as far as like humidity, but like the Dallas isn't nearly as bad. It's like comparable to East Coast humidity. But yeah, after we checked the TD to make sure everything's cool, making sure we had proper liquid, making sure we have the actual liquid in there, and then also making sure that the liquid is at the right temp it needs to be at. Because as they found out, they're like, yeah, the rack floods out when it gets nice and cool. And I was like, yep. Because you tried to open up the expansion valve during the day when the subcooler wasn't working. And then at night when it got cool and the liquid temperature got cool, then you have these sporadic hits of, hey, we're gonna hit the compressors with some nice cold liquid because we're trying to keep them longer. No, it happens all the time, but people don't understand the process of how you need to do these things. I was showing them how to torch the receiver, but you try to find the level.
Yeah, I'm very selective when I show guys how to do that now because I set a rack on fire.
I do preface with the fact that I want the rack, the area that you are going to hit needs to be clean of dust
and oil.
And oil, yes. because it's amazing what like cobweb dust and oil does.
It went wick.
Oh,
Full rack. That from the receiver, it just went across all the compressors. Like, oh no.
yeah. So I did preface when I showed them that because I took a little bit of dust that was there. Like I cleaned off the area that I was doing. I was like, see, look at this. Look at the tinderbox. And I just got close to it and it just flew. And yeah. So once we do that and we verify all that stuff, then we know we have the good liquid. Now we can go down the case, right? Because I say this all the time. We need to make sure the heart and the lungs are working, right? Make sure the compressors are pumping where they need to be, not too much excessive head pressure, not too excessive, too low on the suction pressure, making sure the condenser fan motors are breathing and make sure they're doing its job. I throw this analogy all the time, and people are going to get tired of hearing it. I tell people that energy can't be created nor destroyed. So the example that I give for this is when we raise our head pressure, right? We essentially we put electrical energy in, we're given two byproducts, energy and heat. The more compression ratio we have, the more heat is being generated. So less amount of work or BTUs is being generated. And they need to really understand that because you could be in the middle of summer, high excessive head pressures because of a 20 some odd year condenser and wondering why your rack is having a good old time trying to pull down the cases.
Yeah. I mean, the more head pressure you have, the lower the suction, the more load you put on the rack, the more that condenser in the summertime is going to have to de-superheat, but with the lower suction. Same thing with the high suction temps. If you have high suction temps on your compressors, like that is adding a lot of load to the actual rack because now you have more heat of compression because you're not having that cool, dense gas coming in there. You're having warm, non-dense gas and you're having to compress it. And now the discharge temps are higher. Discharge temps are higher, it makes the condenser less efficient. So sometimes lowering the superheat at the rack can actually help with head pressure issues.
Agreed. I know you and I disagree on this a little bit. You like a little bit more of a leaner superheat towards 22, 25-ish. And I'm making sure that my rack doesn't crash if something floods back. I'm more of a pessimist. So I like having a little bit because most racks are actually designed for 35 degrees of superheat. I found this out the hard way. We had a rack that ended up failing all the cure ones and just tripped them out because the compressors got so damn hot. And it was because it was on the low temp side. All the low temp compressors, I probably had, I don't know, 15 cases, but only 2 were running low temp. Well, so basically the suction line temperature coming back was 65 degrees of superheat. So it was running hot. And so the DTC valves that they put out for the liquid injection on the Bitzers, the engineer who designed it, was like, oh yeah, this rack should run no more than 35 degrees suction line temperature, forgetting that there's Murphy's Law and people that are like, I just want to run all medium temp on my low temp, and causing a really excessive high suction temperature, which in turn caused issues. It was the hottest day in Texas when it failed. It was 115 or 120 degrees out that day. So there was already sprinklers on things. The way that I fixed it was there was no need that we needed to run that low because once again, we were only running 2 cases that were low temp and the EPRs were shutting down on them. So I basically floated up the suction pressure, which I can't do anything with the head pressure because the head pressure is the head pressure, right? But the suction pressure I could do something about by floating it up where the EPRs weren't at 20%. Who cares if they feed more? I'm saving more energy that way and I'm getting the acid into the compressors cooler, so I have cooler oil and everything's a lot happier.
It's the same thing with the CO2 racks in the wintertime. They do the same thing on some of them. If they don't have the flash gas load, sometimes they have high ass return temps. And some of them don't have liquid injection. I've been seeing a lot of CO2 racks lately without liquid injection.
On the medium temp side?
Yeah.
That's scary.
I have 2 right now that definitely need it because the low temp load is we're running a little bit hotter in a low temp. And then I just, for some reason, don't have the flash tank load on these racks. So it's just not getting that wet liquid off the flash tank.
Mm-hmm. What's the flash tank pressure on the one you're working on?
515.
So I'm saying that high. You could jack it up some for temporary.
Yeah, it could. Or we just put liquid injection in. I actually just tanked the case superheats on this rack.
So I need to actually ask someone about, because I had an argument. It was a discussion. We were trying to we've talked about this before, low temp superheat, 3 to 5, 6 to 8 for medium temp. But if you talk to anyone about CO2, they're like 10.
Yeah, why?
And it's ridiculous. So one of the engineers had told me something, and not that I don't believe him, but I always have to do my own homework. But it has something to do with something specific to CO2, and the cases run more efficiently at 10, but it just doesn't make sense to me.
You use less the coil. We have plenty of microthermal sites where we're running 6. And we have awesome control over cases.
And that's my point. Like, you could essentially raise the suction pressure up a little bit.
Well, here's the problem. And this is the hill that I will die on. There's
like 4 of them right now,
lots of hills. They're big hills.
Big hills.
So the problem is you don't ever hit the superheats hardly. You know why? Because the suction's in the shitter. Because there's no EPRs. So you have a bunch of high efficiency cases. It doesn't really matter because you're never going to hit the 6 or 10 degrees of superheat because it's cutting out on temp before that.
Yeah, I know.
So that's a problem.
Maybe they should put more EPRs in CO2.
I 100% agree. Just not it, but don't put bypass check valves around the pulse valves. That was a bad night. That was a bad night for everybody involved.
Yeah. So like I said, after we verified everything, we got on a big tangent there as per usual. But so after we check everything that, and we know everything's good with the case, good with the liquid temperatures, head pressure's good, suction pressure's good, and straight and solid. When I say, not that it's just maintaining pressure, but if you're spending a lot of time where it's going from your set point, let's just say is 55 PSI, and it's going from like 80 to 45, maybe some things have to be done. We're showing some of the guys too as well, what a little bit of tuning will do. And I'm not talking about like case tuning or anything like that. Again, not like case controllers or anything like that, but like getting constant superheat on all 3 valves and getting the EPRs, not that they're hitting that the case temperature isn't actually hitting its set point. Already today, from Tuesday, we went from, I think, 166 cycles down to 42. And it's going down progressively every day because the more stuff that we tune, the more stuff we get feeding more constantly, the rack's just inevitably going to work better. Unfortunately, they have some things out there where they have a big loop, and I've raised the suction to it, I think, enough where I feel comfortable where I could probably go a little bit more once I get some of the other cases spec'd out. But still, they're high efficiency cases and they slam doors on them. Yeah. So we're going to have to probably put EPRs on them to get them up to suitable, because like they're hitting the set point and then cutting in and out all day, all long.
Yeah, no, it's that. The tuning, if you got anything running over 200 cycles a day, it's bad. There's a lot of room for improvement, but not when you have 25 horse and 25 horse. You're probably not going to be able to fix that.
And that was the other thing too, where I was showing them where I was like, hey, look at this. We have to, a couple of stores we've had to verify compressor sizing because they went off an old RS sheet and there had been changes to the system and now the compressors are wrong. And so it's overcycling and undercycling and whatever else, but it all goes back to trying to get it, trying to get the cases that you have at an even superheat and an even case temperature. Because what that also
superheats when you get compressor cycling 200 times a day.
Well, on EPRs, it's a little bit easier, right? But
yeah,
even at the point of having cases more evenly have superheat, even where like you have 1.5 degrees of variance between discharge air temp, because if you don't, you could have one case that's eating shit that's going all the way up to maybe 56 degrees during defrost because the other one's lagging behind because that one's doing stellar superheat because it has more of a frost on it, right? And so when that system goes out of defrost, now you're having to compensate with a heavy load coming back from that one that was getting all the way up to 50x temperature, right?
Yeah, no, you're 100% right. I mean, that is 100% right. if you don't have them balanced and one's way higher than the other, then that becomes a huge issue. It just waste energy. Go ahead.
No, sorry. One thing I saw interesting, and I've never seen this before, so this is a new thing for me. 3 different boxes that are nowhere near each other off of one loop for hot gas.
Oh, yeah. I've seen that.
You have. The day was my first.
Yeah. Doesn't it work that well?
I'm gathering that. I'm really gathering that because I was like, so one of the boxes ended up icing up because the fans were running like during cool gas defrost. So it would just, and if anyone's ever seen
cool gas even, wow.
Yeah. So it's no good. But if anyone's ever seen this happen where they have on a cool gas, even a hot gas system, if the fans are running while it's supposed to be defrosting, basically you have a lot of condensation of refrigerant happening and it all like drops to the bottom of the coil and then freezes like the first like 4 inches of the bottom.
That's why it gets so thick.
Yeah. Cause it doesn't really defrost well, which I guess, yeah. And then it exacerbates, it gets worse because as the ice and frost builds up, until the temperature at set point has changed, yeah, it just keeps icing up and building up more frost at the bottom and never really defrosting because it's just there. You don't have that you don't have the sensible heat change because it's cool gas. You have a little bit, but not much. And then, but you don't really have shit for latent heat exchange because you're basically converting every bit of refrigerant that it is vapor into a damn liquid. So you don't have that change to actually defrost it out.
100%. The only way that would ever like somewhat work in a non-aborted fashion would be using termination solenoids.
I was just going to say that. So once we get all the superheats even, and once we have the fan stats, the fan pan stats set where they're supposed to be, like I'm a firm believer that I think they need to be on the suction line. So that way, as soon as if it's for reverse flow, I should say, right? So as soon as it gets that hot gas load, it's going to kick the fans out instantly. And I had the guys set it for, I think 40 degrees. And then I had them do like a 20 degree differential. So then the suction line essentially would have to get down to 20. They're going to try that first because I forget I didn't have time to look at the saturated suction, but you figure even if you're running at a negative 10 degree box or negative 10 degree saturation, right? You add 3 to 5 degrees of superheat onto that. That's still -5, right? 20 is still pretty high for a freezer. I could probably go 15, but I would just, as long as the short cycle, I don't really care. You know what I mean? You just don't want the fans like sputtering on, sputtering off. But I just gave them a starter point. And later, maybe when I come back to do some more advanced stuff, I'll explain the intricacies, or you have a little bit more playroom here. First, I have to get these guys the basics, and that's basically what I'm doing.
So I found with that, I like to tank them lower, like kind of like you, like 10 degrees, maybe a little less for a fan cut back in. But you got to watch because if you have kind of shitty superheat and your fans may not cut in for a while on pull down, which will lead to alarms from did not pull down fast enough or defrost. Just look at that while you're doing it, and you may need to tweak your superheats if you're not bringing your fans on fast enough.
Yeah, and like I said, I'm a big believer of 3 to 5 on the low temps. You're filling up that coil pretty damn quick, as long as your valve isn't hunting like a bitch. And like I said, cutting out at 40 degrees isn't unheard of because that gas is going to be, at least on cool gas, is going to be 65 at the utmost minimum.
I think you could ask for like a better defrost, though, cutting out like 15 or 10 or 20.
Cutting out or in?
Cutting the fans out at 15 degrees and like back in 10 to 5.
But there, I was trying to avoid fluctuation of fans. So if they cut right out at 40, right, and then like I said, if you do the math and figure out what normal superheat you have, you can cut that fan in when it starts getting all frosty across the board, like more along the lines of 5 degrees. But most click-ons for coil temperatures are set for 28. So really anything under 28 is fine. You just have to, I just try to not make as much cycling as humanly possible, because the more cycling you have, the more wear and tear on whether it be the click-ons, the Ranco, the Johnson control, shit, even a 418. You just want to avoid that overcycling. But like I said, once we get that down, I'll probably take a look at it tomorrow, because they were just de-icing a brick this afternoon or this morning.
Yeah, I'm a big fan of just cutting the fans off on a contactor immediately when it goes into defrost.
If you have that control, sure.
Oh, yeah. Yeah.
The problem is it's easy to do with electric, right? Because you could essentially do kind of like a hustling deal where they have the fan heater that basically energizes, that relay that energizes to basically switch the power from the fans to the pan, which does instantly as soon as you kick on the electric heat, right? But with cool gas, hot gas, whatever, there has to be some kind of thermostatic change unless you're going to run a wire all the way the hell down there. And unless you have a case controller, most customers aren't going to want to really do that.
Correct. It's one of those deals. Well, guys, I think we're going to call it for tonight.
Love you guys later. Thanks. Bye.